Hello, everybody. All right, so we're going to move on to our next section. Now, this is actually a really short section. Your homework questions are only 9 questions on this one. This one, about 90% of it, you're going to use your calculator. So if you don't have a calculator with you, go ahead and grab one real quick, so that way you'll have it next to you. So what we're looking at today is the graphs of the other trig functions. So we've already talked about the sine and cosine graph. So now we're going to look at tangent, cotangent, cosecant, and secant graphs. So that's what we're focusing on in this specific lesson. So let's start off with the tangent graph. So on your unit circle, your tangent graph, if I have all these x values up here, these are your tangent points here. And so you'll notice that it goes from 0 to pi over 2. Now, the reason it goes from 0 to pi over 2 is because if we go from 0 to 180, for instance, you're going to notice that here at pi over 2, especially right here in this spot right here, we are undefined because tangent is sine over cosine, and you're undefined when your denominator, in this case cosine, is equal to 0. Well, cosine is equal to 0 at pi over 2 and 3 pi over 2. So basically all your odd pi's over 2's, like 3 pi over 2, 5 pi over 2, 7 pi over 2, you're going to be undefined at those. So when we look at a tangent graph, yes, we have a period of pi, but we don't start at 0. We go from negative pi over 2 to pi over 2. So if you take a look here, if I'm to draw an actual graph here of what the tangent graph looks like, and so if you take a look at what we have up here, so this is just a 0 to the pi over 2. So at 0, I'm 0, so tangent crosses the origin. And then at pi over 6, which is 30 degrees, I'm at basically 0.6, and so that's what that is right here. And no, I'm sorry, that's actually about right there. And then at pi over 4, I'm at 1, so you know that right here is going to be pi over 4. And then you just kind of keep going up until you get to pi over 2. And if you take a look at these numbers here, notice how we're inching closer and closer and closer to 90 degrees. And as I get closer to that 90 degrees, our numbers really start to jump up, and that's because you have an asymptote here. So when you're looking at this, so I'm above the x-axis here. That's because I'm going from 0 to pi over 2. But if I go from 0 to negative pi over 2, I'm below the x-axis. And if you think about that, this is the first quadrant. This is your fourth quadrant. Okay, so that's where the full graph of the tangent looks like. So with your tangent, first thing, your tangent is going to be an odd function. Remember, I told you about odd and even functions. The only two even functions are cosine and secant. Everything else is odd. And so if you take a look here, if I was to take this piece right here and flip this over the origin, it matches up onto this bottom piece right here, which makes it an odd function. And so then again, you're undefined where your denominator equals a 0. So in this case, your denominator equals a 0 at your 90 degrees and 270s all the way through. So this just kind of reiterates. So if we're looking at your tangent graph, you have a period of pi. Your domain is all real numbers except odd multiples of pi over 2. So we have here 1, 2, 3, 4, 5 cycles of tangent. And these 5 cycles, because remember, your period's only a pi. So we're going from -5 to -3, so that's 1 full pi. And then from -3 to negative pi, and then so on and so on and so on and so on. And so that's what it's talking about. These odd functions here are these odd pi over 2's. So where you see that, that's where your vertical asymptotes are going to wind up being. And then when you're halfway between, so when I'm halfway between 5 pi over 2 and -3 pi over 2, halfway between that's -2 pi, that's where you're going to cross your x-axis. So you're going to cross your x-axis halfway between your asymptotes. All right. And then when you're halfway between where you cross the x-axis and the asymptote, that's where you're going to be at that 1. So if you notice the 1 here, we're halfway between, and the -1 down here, again, we're halfway between. All right. Actually, I just talked about that. So there you go. So if you're looking at how to graph them, so how you read your graphs or whatever. So remember how when we did the sine and cosine graphs, the bx minus c, but the only difference is this was 2 pi. This because you have asymptotes here at these negative pi's over 2's. Now you have to be bounded between here. I still have my period of a pi between negative pi over 2 to pi over 2. That's still 1 pi, but it's just broken up into this way so you can actually see the full picture. You'll identify your x-intercept. Your x-intercept's always going to be between whatever it is that you're looking at. And then in between your x-intercept and the first asymptote and the x-intercept and then other asymptote, that's where you're going to get your 1 and -1. Okay. So this is just putting a picture to what we just talked about one more time. And so on this whole section, you're primarily going to be using your calculator. So you're really going to be taking these pictures here and putting them into an actual calculator and graphing and then just matching, because you'll see when we get to the homework questions that your tangent graphs and your cotangent graphs or whatever, they're going to ask you to graph this graph and then go in there and match whatever your calculator is to what they have there. All right, so now let's talk about cotangent. So cotangent looks like your tangent graph. The difference is that your period is still going to be pi. Your domain, however, is going to be all the multiples of pi. So remember how your sine graph is 90 degrees off of your cosine graph? Well, your tangent graph is literally 90 degrees off the cotangent graph. So whereas tangent, you have asymptotes at every of your pi or your odd pi over 2's, for your cotangent graphs, your asymptotes are happening at the x-intercepts of the tangent graph. That's the easiest way to say it. So as I'm looking at this, you'll notice that if this had been a tangent graph right here, this would have been an asymptote, but on a cotangent, your asymptote for tangent is actually where you cross your x-axis. And then where you cross your x-axis on your tangent graph is actually where you are having your asymptotes at. Still the same kind of setup, vertical asymptotes instead of asymptotes, not asymptotes. Instead of being at your odd pi over 2's, this one's going to be multiples of pi. Your x-intercept, again, always is going to be halfway between. Again, you still are going to be an odd function because you're going to have that symmetry across the origin. And then again, halfway between your x-axis and your asymptote is where your 1 or -1 will be plotted. Same rundown. So remember with pi, and I'm sorry, not pi. Remember with tangent, we went from -pi over 2 to pi over 2. So with cotangent, we're going from 0 to pi because at 0, I have a vertical asymptote, and at pi, I have a vertical asymptote. So this is where you're bounded out. You're still at an interval of pi, except now we can go back to 0. Again, once you do that, halfway in between that is your x-intercept, and then your points of where your -1 and 1 is going to wind up coming up at. And so again, this just plots everything for you so you can see what's going on here. Again, though, you know, you have your, oops, sorry, this point here, this is going to be halfway between whatever this is. So you know if this is pi and this is 2 pi, that this is going to be 3 pi over 2 right here. And so halfway between that, so a 45-degree angle, this is going to be a 1, and that's going to be a negative 1 at the other 45-degree angle. All right. Let's talk about cosecant and secant. Now, we talk about these kind of in the same context as we do with your sine and cosines. The difference is that with cosecant and secant, we are not continuous. So the only two graphs that are continuous is sine and cosine. The other graphs, the other four trig functions, will always have asymptotes in it because you represent them in terms of a fraction. So remember, tangent is sine over cosine, and then cotangent is cosine over sine. And then you have cosecant here, which is 1 over sine, and secant, which is 1 over cosine. Because we have these fractions, we will have asymptotes. And so we look at our asymptotes where these denominators equal 0. So if you think about it on a unit circle, sine is 0 at 0 degrees and pi and 2 pi and 3 pi and 4 pi, so multiples of pi. And cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, so on and so on and so on. So that's how you're going to be taking a look at that as we're going through this. All right. Now, here is the weird looking part. So when you actually go through these, we're talking about a cosecant graph. If I give you a cosecant graph is related to sine. So what you're going to do is you're going to go through and actually draw your sine graph here. And then at every, because this is cosecant here, at every multiple of pi, you're going to draw your asymptotes. And then everywhere you see your either your peak or your valley, you're going to draw basically a U. So the actual graph of your cosecant is going to be in terms of these U's here. These are actual versions of your cosecant graph. So if I take a look here, there we go. If I take a look at this here, so if I can make this bigger. If I come over here and I say sine of x, all right, I'm going to plot that. I might need to fix my window because I think it's too small. Yeah. So I got to wait for that to plot here. So I'm going to make this a little bit bigger here. So give me a second. So we're going to go from negative, let's go 3 pi, just to give us enough room so you can see what's happening here, to 3 pi. Okay. And we're going to go a scale of, let's go pi over 2. The second pi divided by 2. We know that with our sine graph, we have a y max and a y min. Basically, remember, it bounces back and forth between 1 and negative 1. So we're going to just kind of make this a little bit bigger. We're going to go from negative 5 to 5. So we're just going to bring it in a little bit so we can kind of blow this up. Then we're going to hit graph. So this is your traditional sine graph as it is right now. So if you take a look here on this sine graph, so see where we're crossing the x-axis? This is where your actual vertical asymptotes are going to wind up being at. Everywhere that the sine graph crosses the x-axis, those are vertical asymptotes. So when I come over here to graph the cosecant, so remember cosecant is going to be 1 divided by sine x. So when I do this, you're going to take a look here, and there's your cosecant popping up here. That took a second, didn't it? So if you notice, every time I have a peak here, that is where my cosecant will come down. It'll touch that peak and go back up. And again, if you notice right here, there are no, that's where your asymptotes are at. So I'm going to turn off the sine graph so you can kind of get a little bit clearer picture here. So now you can see just the U formation of how this actually works. But you get this by drawing the sine graph first and then drawing your asymptotes at every place that the sine graph crosses the x-axis. And then you just create your U's from there. Okay. So again, sine is an odd function, which means cosecant is an odd function. So again, if I'm taking a look at this, and if I'm looking at this here, right here, going from here to here, I lost my train of thought. I'm symmetric about the origin, so I wind up with the same graph either way you look at it. Okay. Now, domain. Your domain for your secant. Oh, we moved on to secant. My bad. So your secant. So again, it's still going to be the same period. The only difference is that you have these asymptotes that are happening here, and you have asymptotes at multiples of pi over 2. So cosecant is multiples of pi, and then the domain for your secant is the odd multiples of pi over 2. So basically, the domain for secant is the same for tangent. So the domain for secant is the same for tangent. And then the domain for cosecant is the same for cotangent. So if you can kind of figure out how to remember that, that will help you, keep all this in order. And then if you look at your range, you'll notice that our range is going to be from negative infinity to negative 1, and then we're going to break, and then we go from 1 to positive infinity. So we have this area here in between. So I'm going to go back to my graph here. So see this area in between, there is nothing that's happening here. That's because this is where your sine graph goes. Your sine graph takes care of the from negative 1 to 1 piece. Your cosecant graph and your secant graph are going to take care of everything else that's above that. So whereas you're bouncing back and forth between negative 1 and 1 for your sines and cosines, your cosecant and your secant won't bounce back and forth. They're going to be above the 1 and below the negative 1. In that middle part where your sine and cosine are actually graphed, where it bounces back and forth, that is where the range does not exist. For secant, we are an even function. That is because cosine is an even function. And if you notice here, I'm at the origin, well, I'm at the y-axis. The y-axis actually cuts your secant in half. All right. So when you go through this and you're going to be given a problem, what's going to happen is in order for you to be able to graph cosecant or secant, you're going to have to take whatever they give you right here. So like this is the actual problem. And they're going to say, okay, I want you to graph cosecant of x plus pi over 4. Well, you just can't go in and graph cosecant of x plus pi over 4. You actually have to, first off, you have to graph sine of x plus pi over 4. So you have to graph either sine or cosine first of whatever's on the inside. And then once you do that, then you have to go through and draw your vertical asymptotes and then draw the U, depending on if you have a valley or a peak. So when you're looking at these, you have to convert it to its reciprocal first before you can graph. Once you do that, then you draw wherever it crosses the x-axis, you draw your asymptotes, and then you come down and go up, and then you come up and go down, and then you come down and go up. Okay, so that is what you're looking at, and that's how you actually draw secant and cosecant. So this just goes on to show you a little bit more. Because once you draw your asymptotes, then you can go in and actually draw the u's that go with it. All right. The same thing here. You're going to graph 2 secant of 2x. So actually before you graph 2 secant, you actually have to graph 2 cosine of 2x. You graph that first. So you're going to graph this here. Once you graph that, then again, you're going to cross or show where your asymptotes are at, and then you can go through it. Now, when we talk about period and amplitude, it's the same setup, just like we did with sine and cosine. Your amplitude is a number that sits here in the front. The period, you take 2 pi and you divide it by the b because that is still your b. So you wind up with the period for that actual function. And then they gave you boundaries that you're supposed to be in. So pay attention to this because this is what you'll put into your X scales in your calculator, so that way you can match your multiple choice graphs that you're actually be looking at. So as you go through this, you can go through and find your 5 key points. The 5 key points basically are going to be your x-intercepts and then your peak and your valley. And so once you go through that whole entire process, then you draw your asymptotes and you go from there. So there's that. There's where we cross. There's my asymptote. And then you draw your U's. Okay. All right. So luckily though, you'll be doing all these problems in your calculator, so you won't have to worry about dealing with this by hand or whatever. Just make sure you understand where your asymptotes go and understand that you have to graph the original one first, or not the original, the reciprocal. So let's take a rundown out of all 6 functions just to give you a refresher. So we're going to start off with your sine graph. So your sine graph starts off at the origin, has a peak at pi over 2, has an x-intercept at pi, has a valley at 3 pi over 2, and then has a x-intercept at 2 pi, and then it starts over. So it has a range from -1 to 1, domains all real numbers, and your period is 2 pi. And then we go to cosine. Cosine, same exact thing, domain all real numbers, range from -1 to 1, your period is 2 pi, so we start off up here at top at 1. We come down here to pi over 2, that's your first x-intercept. We valley at pi, we come back up at 3 pi over 2, and then we peak at 2 pi, and then we start over our graph. So remember, cosine is a 90-degree vertical shift, not vertical, horizontal shift of sine. Then we have tangent. So tangent always coming up from negative infinity and running off to positive infinity. So that's how you look at this. Your domain is all real numbers except odd multiples of pi over 2. Your range is all real numbers because it does cover everything, and your period in this case is going to be a pi. Cotangent is the reverse of tangent. So we come, as you read this, we come down from positive infinity and we head off to negative infinity. And then we start over from positive infinity and head off to negative infinity. Your domain is all real numbers except multiples of pi. So negative pi, 0, pi, 2 pi, 3 pi, 4 pi, so on and so on and so on. And then you have cosecant. So basically, you're going to draw your sine graph first, and then everywhere your sine graph crosses the x-axis, then you're going to wind up having an asymptote, and then you'll have your u's be touching the actual peak and valley. So if I'm looking at this, see if I can draw this. I'm not a very good drawer, so bear with me. So my sine graph will come down and do this, and then come up here and do that, and then come down here and do this, and then come back up here and do that. So there's my sine graph right there, you can see. Your range, basically, it's not from -1 to 1. So it's all real numbers except from -1 to 1, because that's where your sine graph lives. And then your period will be 2 pi for this one. All right. And then the last one is your secant. So again, remember the domain for your secant is the same as tangent. And then the domain for your cosecant is the same as cotangent. The range for secant and cosecant are going to be the same. And then you have the same period as pi over 2. All right. So again, if I'm looking at this and I'm trying to draw this, so I'm going to start here and I'm going to come down here and I touch here and I go up and then I come up and I go this way and I go off. And so as you're looking at this, this is what your cosine graph would look like. And you can see the cosine piece here and ends right there. All right, so that's all 6 trig functions in a graphing form. So let's look at a couple of your homework questions so you can kind of see. You only have 9 homework questions on this one. So fill in a blank. So your first question is a fill in a blank question. The easiest way to graph 5 cosecant of 3x is first by graphing what? So basically this is asking you what's the equation you should graph first? Well, we know that cosecant is the reciprocal of sine. So we know that we actually should be graphing y is equal to 5 sine of 3x. So this is what you need to graph first before you can graph cosecant. So that's what it's looking for. The next one, determine if the following statement is true or false. So the graph of y equals 8 sine of 3x has x-intercepts at pi over 3. So x equals pi over 3 is a vertical asymptote of y equals 8 cosecant of 3x. Well, so sine is the reciprocal of cosecant, so that's a good thing. It does have an x-intercept at pi over 3, and so since it is the x-intercept at pi over 3, that means that you have a vertical asymptote at that x-intercept. And so when you're looking at this, it's true because x-intercepts on sine curves correspond to the vertical asymptotes of cosecant curve. So when you're actually looking for this answer right here, let me select the right one. You'll come through and you'll pick the one that is correct, which would be that one for this particular question. Graph 2 periods of the given tangent function. So this is a multiple choice question. So basically from here on, if I'm not mistaken, you're going to be doing multiple choice. So they're going to give you this question here, and you've got either 3 or 4 graphs to pick from, and all you're going to do is put this into your calculator, graph it, and then pick which one it matches. And so if I was to take this and plug it into my calculator, I get something that looks like that. So if this is a multiple choice question, I am looking for something that looks like this. And so that's what you'll need to do and go in there. The only difference is it'll have the actual asymptotes that are actually showing. All right. And then the last one. So this is a 2-part question. So the first part is, what's the equation of the reciprocal function? So if they give me this here, I need the reciprocal function of this. So remember, the reciprocal of sine would be cosecant. So everything else stays the same. So I go y is equal to negative 1/4 cosecant of x over 4. And so that's what would go into the box right here. And then you would hit enter, and then it'll say, okay, then graph it. And so what you would do is you would come over here and you would find all your vertical asymptotes. So everywhere it crosses the x-axis. So let's see if, oh, you know, I got a line tool here. So come over here, and everywhere it crosses the x-axis, I am going to draw a line. Just going to make sure I draw the lines correctly. And then over here on that one, and there's one more on that one. I know I missed both of those way bad. Let me fix that. And then I do that. So there are my vertical asymptotes. And then I come in here and I graph this. So the easiest way to do it is just start here. And we run down this direction and that direction. We go up and up. And then we go down and down. And then we go up and up. So that should be something what your graph is going to wind up looking like. So once you put the equation in, it's going to have you do that. And so you just walk through and draw your U's the way that they're being drawn here. All right. All right. So this one was short and sweet. Again, you're going to use your calculator for like 90% of this whole entire homework. So just pay attention to what's going on in there. And hopefully that wasn't too bad for you. Hope everybody's having a great day, and I will talk to everybody when I can. Remember to send me questions and emails, or send me those remind questions. And if you're clicking the Ask the Instructor button, please make sure you send me an email so I know, because it does not go to my high school email. It only goes to my PJC email. Okay? So y'all have a great day, and I will talk to you soon. TTFN. Ta-ta for now.